Good afternoon and welcome to the latest webinar in a series by Elemental. This is brought to you in association with BEAMA, the UK Trade Association for Manufacturers and Providers of Energy Infrastructure Technologies and Systems. And today, the context really for the discussion today is that the UK government has laid out its 10-point plan for this new industrial revolution. It's going to be up to the industry though to align sort of the skills, the workforce, and to actually make this happen. So the decarbonisation of heat over the next decade is going to require expertise in hydrogen and electrification, and that ability also to develop coordinated systems in people's homes. So today I am delighted to be joined by a panel of experts, joined by Richard and Mark here with me, who I'll introduce in a moment, for the heating industry, to really discuss how the existing skills in the industry can perhaps be redeployed and perhaps what new skills are going to be required. So just before we do get into the introductions and I ask these people to introduce themselves, a couple of notes. Just do ask any questions. If you've got questions, fire them away in either the chat or there's a Q&A feature, and we'll try and get to that when we can as well. So very happy to take your questions on this, but I also have some of my own. So anyway, delighted to be joined by Mark Barson, who is Future Portfolio Manager at Vaillant Group, and Richard Burrows, who is the owner and director at Mid Wales Plumbing and Heating Supplies. Welcome, gentlemen. Mark, would you like to go first with a quick introduction?
Yeah, welcome. Thank you for that, Ben. Yeah, my name's Mark Barson. I've been in the heating industry 35 years, been involved in design and manufacture of boilers, product manager for heat pumps, been actively working in heat pump design installations for the last 15 years for Vaillant. And I'm quite an active member with the trade associations and with government support.
Brilliant, thanks Mark. And Richard?
Hi, I'm Richard Burrows. I'm Director of Mid Wales Plumbing and Heating Supplies. I'm an ex-installer. I came off the tools 6 years ago, and we supply anything from gas boilers to heat pumps and all sorts of plumbing and heating items.
Perfect. So, yeah, you're a perfect person to talk to then about what are the different skills that are required then for the decarbonisation of heating. And actually, are they that different?
They're not that different, really. I mean, we're still just talking about a heat appliance, so we're still trying to put heat into systems. The key differences with heat pumps to gas boilers, obviously, we're working with reduced flow temperatures. So instead of our gas boilers running at maybe 70, 50 or slightly less, we're now talking about technologies that run ideally around the 35, 45 degree flow temp mark. So we do need to have a little think about our heating systems a little bit more than we probably get away with traditional gas boilers. But certainly, as far as the technology goes, it's similar technologies.
Yeah, and then I guess from a technologies perspective, from a Vaillant perspective, Mark, would you confirm that?
Yeah, I mean, I'd absolutely agree with that. Richard's right. Boilers are more forgiving, aren't they, in terms of the heating system that's in. And we need to just take that little bit more care, but knowing that what we're doing is transmitting heat and energy from a source into radiators or underfloor. So we probably need to think about the design a little bit more careful about the heat loss of the property, mean water temperature flows, hydraulic flows, pipe sizing, things like that. But most installers should have been aware of this anyway. It's just a matter of thinking a little bit more in detail about it. Of course, there's a difference between new build and the retrofit market as well, where we need to really analyse currently what's in an existing home and seeing what needs replacing, if anything, for the radiators and flow pipes.
Yeah, and so when we get into that difference, I imagine the retrofit is a lot more of a challenge. Would you, Richard, sort of nodding along in agreement with that?
Yeah, it's going to be. I mean, being quite frank and honest, the retrofit market is going to be the most difficult market to put heat pumps into. Just basically on what Mark said there is obviously we've got to think about the mean water temperature of the heat emitters, because we're now potentially going from a mean water temperature of maybe 50 right the way down to 30 or less. So we have some associated problems with that. Is obviously because we're increasing the flow rates through the system as well. So the heat pumps prefer a differential of like 5 degrees Celsius, where our gas boilers are running at DT20. So what that kind of means is they have 4 times the flow rate than a gas boiler potentially would into a heating system. So we have to think a bit more about pipe sizing. Are the existing pipes, the correct size to deliver the correct energy to the heat emitters at the correct rates? So yeah, heat emitters going to be different. You got to get this stuff right. So like Mark said, the thing with gas boilers is it's forgiving, because if you design it at a certain temperature, if you design it for a 50-degree system, so 50 flow and 30 return on a gas boiler potentially, and you get it wrong, you can always turn the flow temperature up. Where with heat pumps, we're not going to have that sort of diversity available within the appliance. And if you don't get this stuff 100% correct, then it's gonna turn around and bite you in the backside quite heavily.
Yeah. Okay. Yeah. Interesting. So and then talking, kind of bringing it back, if you like, to the skills and what we need to develop and the installers perhaps that we need to train up. I mean, there's a big gap, isn't there, at the moment, if you like, between I don't have the exact figures, but something around, is it 1,000 just like trained installers today, and we're probably estimated that we might need 25,000 plus in future.
I could pick up on that. I mean, where we sit today, there are less than 1,000 MCS installers qualified for fitting heat pumps, and with the government's target of 600,000 heat pumps in 2028, we're going to need something like 25,000 installers to meet that demand every year. And I would imagine that we're going to get installers moving from the gas side into heat pumps, but we'll probably get I hope we'll get some apprentices, moving up through the ranks that have been trained from day one into understanding what's required to not only fit heat pumps, but to fit low carbon, higher efficient systems as well. Just because they're taking that route doesn't mean that they're not competent enough to put gas boilers in. We're going to be selling gas boilers for a considerable length of time, and that market will need maintaining as well. So there's a challenge there with installers, and they'll come from gas installers and new.
So what do you think what are the best ways to perhaps, is it incentivize installers, or to encourage those to train up? What can we do differently than we're doing today?
There needs to be value in fitting heat pumps right through the supply chain. So there's some education that needs to be done at the public level, at the consumer level, focusing particularly on off gas, around reduced carbon, but around energy saving and fuel saving bills as well. That's one of the first things that needs to be done. And there needs to be that pull for heat pumps through the supply chain. And with that pull and certainty of a market going forward, installers will come to that. They want to grow their business. Installers are inquisitive in the main, and they'll want to grow and develop that business, but they need that security to invest in their business.
It is that security, because when the last wave came round, so back in the early 2010s, I was in business investing in renewable technology, and investing in training, taking time off work to go and get trained, looking, and it was the education side, because that's the bit I was lacking. So lacking this transference from gas boiler heating over to renewable heating. And that takes a lot of engineers' time. So it's a lot of investment from their side, a lot of their time, and then not to be rewarded, which everyone who got trained in the early, like I said, 2010s, the government pulled the plug on it. And the issue is that without that stability or that guarantee that after your training, you'll have something to, you'll have the installations to go and do, you'll have the customer base to go and satisfy. That's a big thing for the government, and they need to, one thing is the training, but they need to ensure that once the training's completed, it isn't just a one-stop, you do your training, then you're going to jump straight into renewable work. It work like that. There's going to have to be incentives, there's going to have to be The databases need implementation correctly to expose these guys to their customer bases. There's a lot of work to be done in between. So it's not necessarily just the training or the manufacturer led, push and influence. This is what we've got, guys. This is what we can do. It's much bigger than that. And without it almost needs a handhold scheme right the way from here's your gas boilers, here's your heat pumps, and we're going to hold your hand all that way until you get to your heat pumps and you get your first job and you get that out of the way. Because without that, you lose confidence between your training and your first job. And there's a lot of questions, and I found there was a lack of support, and the sales reps at the time didn't have the knowledge themselves to help and handhold you and guide you like they would with the gas boiler. Yeah. So it's all part of the parcel, really. As from the training, from doing that, going and doing the training right the way through to fit in your first renewable systems. And that's a long, I think personally, I think there's a big gap between there and there, and that's what needs to be filled. And I think it's quite daunting. Is it because it's really, we've got to think. I think we're in really innovative, and it's not new technology. This is old technology, but we're in innovative times where people are starting to think about carbon reductions or energy reductions. I don't necessarily like to talk about carbon because it's more to me about energy reductions and implementing technology that's right for the right property. So there's quite a lot to do.
There is a lot to do, but I mean it's exciting times for us that have been in it from the start to see that door finally open. And there being some incentives. We've seen an additional year being put on the green homes, which takes us through to what is potentially the clean homes. So we've got continuity now from RHI into future funding, which is something we lobbied for, because nobody can build a business on a spike of an incentive, can they? They want to build it on longevity of installation. And the training aspect, you picked up a good point there, Richard. A lot of this is done by peer, by taking an apprenticeship who's got his base qualifications in low carbon and heat pumps in a national training academy, low carbon training academy, but he needs that on-site development and a peer to look to, to help him through this process till he becomes a professional. And that's something we really need to work on that as an industry. Whether we can, put apprentices with organisations, I'm not sure what the answer is there, but it's something they would really benefit from.
Yeah, that was going to be my next question.
I was an apprentice.
Yeah, go on.
Yeah, well, I was an apprentice, so if you're heading that way anyway, Ben, then. But,
I was going to say, is apprenticeships the best way to sort of like get these guys up to the school? Like,
I really like apprenticeships. I mean, it literally. I did an MVQ level 3 and I did a HNC in mechanical engineering. So I really like the on-the-job learning. We had a 2-day release at college when I was doing it. And at 16, when I left school, I had no clue what I wanted to do, but I knew I liked engineering. I liked playing with cars. I liked taking things apart. I knew kind of what I wanted to do. But the company I joined at the time, which was JB Engineering Design Limited in Suffolk, they had a really good apprenticeship scheme. And basically, learning off your peers was critical. So having the experience within those companies, having the ability to go to those people and learn from years and years and years of experience was fundamental to my learning anyway.
Yeah, I think in terms of that apprenticeship route, it's an essential route going forward. There needs to be parallel paths, don't there, as well, though, for those that want to take the expert route, that want to convert, from a good boiler installer into heat pumps as well. There needs to be that route as well. Yeah,
because that can be one of the things. And I'd like to welcome John Trenell into the conversation as well from Tailored Heat.
Sorry, guys.
Brilliant. Thanks. Thanks for joining. We're talking about what are the best ways to actually kind of deliver the training and to get the people up to speed and with the skills that they need for heat pumps, for the electrification and decarbonisation heat. Richard's sort of a big advocate of sort of the apprenticeship programs, and then I know John, maybe introduce yourself a little bit, and then perhaps your opinion on that as well, and perhaps also how we handle some of the I don't know, should we say more experienced workers who perhaps have a set way of doing things.
Yeah, I think my name is John. I'm not an alcoholic yet, but probably by the end of lockdown I might be. I've been in our industry for a number of years too, designing and supplying heat pump systems, and in my earlier years we used to be contracting, so we were doing the bigger 320, 400 kilowatt ground source heat pump systems. But the consequence of that is that I'm involved in the MIS 3005 standards committee, which is all for MCS, the microgeneration certification scheme. I'm involved in the Heat Pump Association, just like Mark and these guys are. I'm involved with SIPFI. I'm involved with SIBSI, the Chartered Institute of Building Services Engineers, and I sit on their domestic building services panel. And also, I'm also part of BEAMA, so I sit on their technical panel for the underfloor heating industry. I actually chair that one. That does make me a little bit sad, but I'm all right, and I try and make bad jokes, or as my kids call them, dad jokes, as we go along. But to your point, I listened, and I totally agree. You know, apprenticeships, fantastic. Early learning, fantastic. But there's an element of we're here and now, and there's an element of the guys who are installing things today are not the apprentices of the future. They are the installers today. So I kind of agree with Mark. There is a, you know, upskilling of what our current workforce is important, and I see two routes to that. Is well, three routes, I suppose. One is you can attend training courses, etc., etc. I think you can't beat on the job training. So I think that the businesses, so for example, I commission a lot of heat pump systems, and we insist that the installers are with us, and we use that half day to a day, depending how well they've installed it, to be educating as we're going along. It's not just a commissioning and setting it to work, demonstrating it to a homeowner. It's actually educating the installers on what we all need to do for the living. You know, when we've chatted about this before in the pre-meetings, it's about, I've summed it up as awareness and then taking responsibility for it. So you don't have to actually know how to do the math. You don't have to know how to do this. Just be aware that, listen, there is some maths to do when you're sizing heat pumps. There is maths to do when you're sizing pipes and selecting pumps and delivering flow rates and selecting emitters. Just be aware that you need to do it. I went on a little forum last night, and I just asked the question of an installer forum. You know, if you could take one piece of advice to somebody who's installing heat pumps for the first time, what would it be? And I've had such a wide range of responses. It's quite interesting. You know, I just wanted to ask the question for fun. But it all comes down to being aware. You know, we want the installers to be aware of what you're going to be doing, and if in doubt, ask.
So one of the questions, I guess, that sort of throws up is, so how do we really maintain the quality standards without, you know, this kind of exponential increase in bureaucracy or more paperwork or those sorts of requirements? And I don't know, Richard or Mark, if you kind of have views on that, and then come back to John.
No one likes paperwork, Ben. So especially me. So I'm definitely not one for paperwork myself. Yeah. Part of, like I said, my apprenticeship, you are taught to do paperwork, but that was one of the reasons I thought I was going for an apprenticeship, was because I thought it was going to be less paperwork, no college. That's what I thought. No, I'm not going to college, am I? So, but you know, fall on me, wouldn't it? I didn't realise the ramifications of doing an apprenticeship, but probably the best thing I did. But paperwork is definitely, I hate it. So having to expect a one-man band to go out, install, and then come home at night and then spend time 10, 11, 12, 1 o'clock in the morning doing paperwork. Who wants to do that? So I discussed a few things, with some colleagues of mine, and they were saying, well, the way heat pumps are geared up these days, they soon tell you, you can get remote monitoring. You can tell off the heat pumps if they're working correctly or efficiently. So a lot of it could be remotely monitored potentially. That takes a lot of the paperwork away. Basic level stuff, pretty similar to benchmarks that we have to complete with gas boilers now. But whether manufacturers would want, I don't know whether whether manufacturers would want to do it, but the manufacturer could turn around and say, actually, this heat pump isn't running very efficiently. We can see it's only got a COP of maybe 2.5, or I don't know. I know there's a lot of things about 2.5 is a minimum standard or something like that, isn't it? I don't 100% know, but say it was running at 2, so for every kilowatt you're putting in, you're getting 2 kilowatts out. The manufacturer would see that and could go back, and maybe it could be all part of the learning process and the ongoing process of learning, because there are fundamentals initially. So get the right pipe size. They need to be this correct pipe size. You need to do it like that. Don't do it any smaller. Heating systems need to be minimum of 15 mil, depending on the size of the output of the emitter. So all that basic level stuff can be done and is quite easy to transition across to. But ultimately, when we're putting these things in, we need to make sure they are running efficient. They do need to especially for RHI, they need to run at a certain level of efficiency and a certain flow temperature to obtain the correct payments for that RHI. So I think it's got to be more of a two-way street rather than just, here's your training, go and do your job and get on with it, and potentially get all these installations incorrect, isn't it? If there's no feedback or any monitoring, I think. Well, certainly that's how it works with gas boilers anyway, gas boilers are put in and not necessarily set up to achieve their maximum efficiencies, which we've talked about before. So
MCS, as you say, Richard, MCS was put in place to really safeguard the consumer and also the government spend for RHI, but it's not suitable for a mass market, which is where we're going, and it needs streamlining without impacting on quality, which is the challenge. I think if as you said, John, awareness of what installers need to do, qualifications, training, all go a good way to making sure that we've got quality in the install, which is important, isn't it? And installers with pride, and the most installers have got pride in what they're doing. They maybe just don't know exactly how to do some of the new things, and there's a joining up of elements there to give them the skill sets, the confidence, and that will give them pride in what they're doing, and that will deliver a more quality install than having none of those at all. We do need I think we still need some kind of a framework just to make sure that we're doing things in a more formulated way, but without the bureaucracy of MCS. So in retrofit, we need to assess the installation. We need to do a design. We need to install. We need to commission. We need to put benchmarks in. We need to register all those things. So, but it needs to be a flow of work which is natural to the installer and not against the flow of work.
Yeah, and it's a difficult balance, because one of the main drivers when the first MIS draft was written was because all the MIS standard actually does is point you towards the British standards that we as installers should all be following, irrespective of whether it's a heat pump or a boiler or an upside down man on a bike. All MIS is asking you to do is document what you're saying, and recognizing that, Richard, and to give you some light in your tunnel, the MIS standard's just splitting at the moment, isn't it? So the MIS standard is splitting to a design standard and an installer standard, recognizing that not all installers have got the skills, capacity, resource, however you want to label it, or any of the above, combination of the above, so that you can actually, as an MCS installer, use a subcontract designer to do your, or an MCS designer, either or, to do all your design work. So they can do your heat loss calculations, they can do your emitter size, they can do the important stuff, Richard, which will allow the manufacturers to remote monitor. Because if you're not getting your efficiency out of your heat pump, in my experience, it's flow. Flow rate is king. Yeah. Every single time. And if your pipe size is wrong, your pipe size is wrong. You don't need somebody to dial into a heat pump to tell you that. You know, you should know it before you even start. You know, a 14 kilowatt boiler needs nominally 40 odd litres a minute through it, which is the same as a 30 odd kilowatt boiler. So just some basics awareness will help us do all of that. Mm-hmm. And interesting, you were saying about benchmark certificates, that's all we have to complete. And when you're commissioning a heat pump, we complete the benchmark certificate for hot water systems just the same as any other boiler installer would, and we complete the benchmark certificates for an air source heat pump or a ground source heat pump. But you're right, the paperwork is onerous, but unfortunately our heating industry in general made the rod for its own back 15 years ago. We're paying the pain. You know, but we have to prove it because there's money involved.
Yeah. And I mean, some of that for me was the issue. So when we used to go out to specify a solar panel on the roof, you know, going out, having to take your little drawing out, do a drawing of the property, the location area where you were proposing to put the panel, you know, getting the customer at that point to tick all the boxes. It was all time consuming. Certainly we don't do that with gas boiler industry. So we go out, you know, it might be a distressed purchase, which means all of the potential heat pump market, which will replace older boilers. Potentially you'll be swapping them boiler for boiler instead of boiler for heat pump, because that customer is not willing to wait for a week or more before you've had to do your 7-day cool off, or you know I know there's ways you can get out of that, but it's quite rigid and fixed in stone, where you know the guys I know and the guys who I've been involved with training and things like that, they just won't put up with a system like that. They just won't. It's just too much work.
I think if you just, you know, we offer. I run an MCS umbrella scheme. I've been running one for over 9 years, and you know, everybody seems to hate, you know, call it it's like a dirty word. We don't call it an umbrella scheme. We call it an MCS subcontractor scheme, because we know what the rules are. We know how to work within them. You know, we design it, we supply it. You do what we ask and install it to the best of your abilities. We'll come out and police it and check it over and commission it and everything like that. We insist on it has to be one of our engineers that does it. It's not something we do remotely, because it remotely can't pick up that you haven't put a guard over the discharge point from your cylinder outside. You know, we can't do all that. I think you find the right partners to work with. You know, Vaillant, your Mitsubishis, your Vaillants, your reputable businesses, and you'll find a way forward. We have a lot of success with repeat customers. We're not big. My business is not big. Don't get me wrong. I'm not professing to be something we're not. But I think you find the right kinds of companies, and Richard, people who are saying, you know, if we want to me, I want a good installer. What Mark said before, that we all want to take pride in our work. If we've got an installer who's prepared to take pride in his work and listen to our advice and follow our advice, then, you know, we're not perfect, but more often than not, the system will be fit for purpose. You know, we call it no calls at Christmas.
Yeah.
You know, as long as I don't get a phone call at Christmas, I'm really quite relaxed about life. And the skills still come back to, I think it's responsibility. You know, you're under pressure on price all of the time. That's the big one is. So we just want you to make that one visit you've priced for to install it and set it to work, and then come back with us to commission it, and then hopefully not have to touch it again until it's time for a service.
Yeah,
that's what
I Yeah, I always personally feel though that if you have, if anything needs someone else to hold your hand, it's a system that's doomed to fail. Because if you can't do as a one-man band, if you can't go out to a job and do it on your own because of policy or you know, I appreciate it's other people's money, so there's a level of accountability, but I always think systems are always doomed to fail if they're over complex, you know, and even umbrella schemes, as streamlined as they try and make it, it's still an additional path that an installer has to take who doesn't want to take his own MCS on.
I mean,
do you know what I mean? And
it's so very difficult, isn't it? Because when installers were left to their own devices 15 years ago, more often than not, they were getting it wrong.
yeah.
Even though you have all been trained and should have the knowledge to do all of this, it's all there and written, it's embedded in your training. It just isn't. It wasn't being done. So you have to start somewhere, and it's really difficult. You know, the downside of heat pumps is that, and it's exactly the same with electric car charging points, you need permission off the DNO.
Yeah.
That's not an MCS requirement.
Yeah.
Yep.
That is not, it's just something that has to be done. But,
Yep.
you know, is your installer aware of that? No, but if you come to the businesses, they'll let you know that actually, guys, you do need permission for that. I'm sorry, but that's the way it is. That's nothing to do with MCS. You know, filling and purging systems properly is nothing to do with MCS. That's good practice.
So I'm going to move on to a couple of questions, because I think we're already touching on. Paul Williams is asking about, for probably, you know, the small businesses, for the micro companies that, you know, one-man bands perhaps we're talking about, you know, I don't know, he was saying will they struggle to get MCS and everything required? You're making a point here, you know, it's not just about MCS, but it's making this transition into what's clearly a more perhaps complex system where kind of everything plays a part.
I think it is difficult for smaller companies to get into MCS and to justify spending the time and money in staying in that quality framework. You know, you've got to have either a mindset or somebody within your company who's prepared to operate in something outside, which is normal installation, that quality framework. And it's a challenge for sure. I don't see MCS or equivalent going away in the short to medium term, because it's there to protect the consumer. Because of, you know, in a fledgling industry, which it was, you know, 10 or 15 years ago, the consumer was at risk. But that's not to say that, you know, MCS needs to be brought into the mainstream, and it needs streamlining. Yeah. And the discussion, it was interesting to hear Richard and John earlier about that, because there are places, you know, for both of those. Some installers will want to move in and become MCS accredited, as well as gas safe, as well as their hydrogen skills. And some will want to operate under a different format. I don't like using the word umbrella, so I'm not going to use it. But I know,
subcontractor,
subcontractor scheme. And you know, and those, there's room for, in my opinion, there's room for those installers as well. And I mean, that subcontractor scheme, I know, takes a lot of back office support to get it right. A lot of back office support.
Tell me.
So the quality is definitely in there. There's no loss of quality. So there's routes for both. So I mean, if a bit of advice there, you know, get some training first of all in low carbon and heat pumps if you want to go down that route. If it's new to you, speak to everybody that you can about it, and then consider which is the best route for the time you want to enter that market.
I think it also moves beyond heat pumps, though. You know, we're talking about skills for decarbonisation. Let's not get hung up on heat pumps and MCS. Let's talk about, we talked about this as well, let's talk about low temperature systems, because actually that's in new building regulations. New building regs are saying that we should be designing our heating systems with a maximum operating temperature, if I remember it rightly, of 50 degrees C. So your radiator sizing with a boiler is going to be low temperature by default. What does that mean? But I don't think I think there's a real potential here to make the same potential errors as you would with a heat pump. You know, if you're told to run your system at 50 degrees C flow temperature, and you've not sized your radiators correctly, and you've not sized your pipework correctly, because as your temperatures drop, your delta T, the difference between flow and return temperatures change, which impacts on your flow rates. It's not that the boiler can't do it, don't get me wrong, but if you're not allowed to turn your boiler up to 60 degrees or 65 degrees because building regs tell you it has to be set for 50, we've got the same problem. And then I can see it in a couple of years' time, a study coming out saying all these low temperature emitters aren't working, boilers at 50 degrees are rubbish. They're not. If you took a boiler out and put it in the factory test and ran it at 50 degree flow, it'll be really, really efficient.
Mm.
But if we get the pipe sizing wrong and we get the emitters wrong and the controls wrong and the integration wrong, because we haven't been aware of it, and we've not taken responsibility for it, and we've just done it because that's what the rule of thumb used to be 10 years ago. That's the thing. And I don't treat a boiler system any different to the way we do a heat pump system, to the way I do a biomass system, to the way I do a hybrid. We've got systems running off hydroelectric boilers and all kinds of weird and wonderful configurations. But you can't change the law. I call it, you can't change the laws of thermodynamics. It doesn't change. The maths is still the maths.
The maths don't lie, so
No.
my mate Rob Berridge says. So
yeah. If we do, yeah, I've seen him. Yeah, I've seen him on.
Well, he's heat engineer. He does the heat engineer software. So I asked him for a comment last night because the first time I joined the Facebook page to talk about it. But it doesn't lie. You know, you'd be surprised how many consulting engineers we've had to talk about basics. And I don't mean it as an insult to them, but because they're interested in a whole big holistic point of view. Yeah. I'm talking to them about underfloor heating basics and having to say, you know, the function of flow rate, and that they're asking us to limit a floor surface temperature to 27 degrees with a design room temperature of 24 degrees and a heat loss of 100 watts a square meter. And that math doesn't lie. Yeah. But I really do feel when it comes to skills, you know, it's fundamental skills, but it's across board. It's not across a product specifically. It's going to be the same skills for a boiler, as a biomass, as a heat pump, as whatever else. You know,
and how about hydrogen? This is a question in here as well. It's quite a broad one about how does hydrogen fit into the picture there, and sort of from a skills perspective. I mean, there's a point to sort of stand there, John. Is there anything else that you want to?
I mean, I'm really talking about integration and emitters, and from that point of view, to quote one of my senior engineers, it matters not. You know, how you generate the heat, we're not fussed whether it's boilers or heat pumps or biomass, but maybe Mark's got a better steer on hydrogen in the way that's coming.
I can give you a bit of background on hydrogen. So, I mean, hydrogen heating in general, domestic heating, is going to play a significant part in the journey to 2050 net zero carbon. It has to, because we can't heat all the homes from heat pumps because we don't have enough copper in the ground to flow the electrons around. So that's fact. The recent 10-point plan that Boris put out there talks a lot about hydrogen development. We're active in hydrogen boilers. In terms of skills and training, there is, I'm just racking my brain, there is a draft course already put together to support the growth of the hydrogen village in towns towards the end of the 2020s. And that will be focused on gas-registered installers with specific skills to put those hydrogen boilers in and to commission them as well. So it won't be a rollout skill, but it'll be one to convert them. And hydrogen will play a key part. And I think in 10 years' time, we're going to see installers who are skilled to work on natural gas, domestic and commercial, heat pumps, small and large, air and ground source, and hydrogen. You know, there's going to be installers with those skill sets who want to operate in those areas. Not everyone will, but some will.
I'm really ignorant when it comes to this, but do the same sort of efficiencies of the boiler stick, whether it's hydrogen or gas? It does that, you know, that's because where I'm driving it towards for a conventional installer, you know, from the boiler out, it's still the same.
Yeah,
you don't want to lose sight of
I mean,
it or be scared of it, you know.
No, I mean it's the white box on the wall from, you know, from the outward into the cylinder or into the tap and into the radiators. It's the primary fuel that makes it different, and the carbon value of that primary fuel. It's how the hydrogen's actually created in the first place, whether it's using renewable energy sources or you know more carbon intensive, carbon intensive electricity to get hydrogen from natural gas. And the other point worth just throwing out there as well, because I've had a lot of conversations on this, is that, you know, heating is not the only area looking to hydrogen to solve its carbon problem. Transport is. And actually transport is far ahead of where we are with heating at the minute in generating hydrogen, which is fuel cell grade for vehicles. So ITM Power in Sheffield, for example, are just commissioning a station in Birmingham to start that off as well. And that's why going forward, there's no silver bullet. There'll be a mixture of hydrogen, heat pumps, and for some quite considerable time, some natural gas as well.
I mean, the overarching thing is whatever it is, we need to make it. Need to make it efficient. So there's some, you know, some of the key areas need to be in the hydronic design, which Kim, you know, I don't know if you heard of Kim Betty, does Heating Academy Northampton, but he specialises in hydronic training. And, you know, some of the key elements that John was talking about earlier about, you know, making sure you got your flow and your returns right, got your mean water temperatures correct, got your pipe work design, your emitter sizes correct, things like that, they're all covered. So, you know, but the ultimate thing is, irrespective of whether it's natural gas, hydrogen, heat pumps, you know, the technology's got to run efficient, you know, and that's, you know, to sort of, the overarching thing is that the hydronics need to be right. So at the moment, you know, it seems, I read a couple of things and publications out at the moment that just saying that, you know, installer base isn't ready. So, you know, the installer base, you know, just on hydronics alone isn't ready. So yes, they can put a boiler on the wall, but making these things efficient correctly and, you know, getting the maximum performance out of the products that are installed is the thing that most installers miss, you know.
Yeah, I think it's a balance. I think it's all about balance. That you know, that adage, keep it simple, stupid, really works. We use that in group, and we generally have a, for want of a better word, it's a one schematic fits. You know, the 80-20 rule. The one schematic will fit 80% of what we do for a living. And it does genuinely. And it's not technically perfect, but if it delivers the correct flow rates throughout the system, it's better than trying to do something technically perfect and do it, dare I say, I'm going to call it the Scandinavian way, yeah, or do it the German way or whatever, because our installer base isn't trained in the same way. It isn't trained in the same way. The houses that we're working in are not, you know, you go into a lot of these European countries and they're building houses and they have this thing called a plant room. We have this thing called an understairs cupboard. You know, that we're not, it needs more than us as installers. We need our designers, you know, the architects to give us space to be able to do things properly. And you know, and that's another side of education we haven't gone down, but you know, that installer, it's getting your control systems correct. You know, it's all about consumption, isn't it? If we can reduce the consumption by giving, for want of a better word, individual room control, then that's no bad thing. That does create an issue with certain products, for example, some heat pumps that are not inverter driven with water volume. So you just have to be aware of it. But you know, it also creates problems with air source heat pumps with volume for defrost, doesn't it? But that's not about that. That isn't about delivery of the heat. That's just about managing the system and the efficiency of the system. So we have to get that balance of integration out. The advantage of, for example, buffer vessels in parallel gives us 2 independent flow rates. It gives us an independent flow rate for the heat generator or heat source, and that's whether it's a boiler or a heat pump. So it can work away to its best efficiency. And you've taken out a whacking big pressure loss through a plate heat exchanger on your emitter side, so you can get better flow rates for the cost of a pump. People like to think that putting an extra pump in the system is less efficient, but if you're delivering better performance because of it, it's not. You know,
it's minuscule these days anyway, isn't it, with pump efficiencies? Because they're, you know, pumps, you know, compared to pumps of old, a million times better than they used to be. Yeah, so, you know, for the cost of a pump, or like you said, a buffer vessel normally cures a lot of sins, which always made me always think why, you know, buffer vessels never got fitted to all boilers, because seems like a pretty obvious solution for something that's on-off controlled, isn't it? You know,
cost, isn't it?
Hey, well, this is it, but the cost to who though, isn't it? The cost to who though. So that's the.
And on that cost to who, there's a couple more questions I want to try and pick up before we go into kind of our final message to take away. Rob Whitney, hi Rob, is asking about, should the subsidies for renewable installations perhaps be spent on installer training or upskilling instead? Would that perhaps be a better allocation of government money and incentives like that?
I'll take that to start if you want. I mean, I think I mean, that's two different audiences, isn't it? I mean, the current subsidy is aimed at supporting the homeowner to make the transition from a fossil fuel to a heat pump. That needs to stay in the short term until it's a sustainable business that installers can invest in. In terms of, if I understood it correctly, in terms of training for installers and upskilling, there should be some support for them taking that day off work and being upskilled and trained, for sure. I'm not so sure it should be free, because it needs to have value to it, but it should reward them for their loss of pay that day. But back to the point I made earlier, if we've got a pull of the heat pumps into the market, installers will come and do that upskilling, be happy that they've taken the voucher for not losing that pay that day, be upskilled, and then more importantly, use it. So they'll be using that skill that they've been trained on nearly straight away. And that's an important thing for me. We need to get that whole supply chain moving and self-perpetuating, and then people will come into the bottom, whether it's, you know, designers, installers, whoever.
Yeah. And another quick question, maybe this one, maybe for Richard or for John, you know, just how easy, someone anonymous is asking, is it for installers to upskill into, I guess, installing heat pumps, for example? But, you know, would that be an easy place to start? We're talking about low temperature overall. Richard, your experience?
Yeah, I think it's, well, you know, it is easy. So it's just that knowledge. It's just that knowledge gap. So, and that knowledge gap might be quite vast, because, you know, combi boilers have been, you know, the overarching sinners really, because they're so easy to put in. They're modulating, so you can get away with anything. You know, there's no real thoughts behind design or heat emitters. You know, where now there's got to be more thought behind the design. You know, the heat emitter's got to be correct. The heat pump's got to be the correct size for the property, you know, at the, you know, deemed, you know, external design criteria. So you know, there's a lot more that goes into it now. So yeah, the actual upskilling of people who are already doing installations, you know, it isn't difficult, but it's obviously varies on the knowledge that they've already got. So like I said, you know, good, you know, get on a good hydronics training course, because once you understand the fundamentals, you can take it from there, you know.
That's where you,
I don't think there's a lot of upskilling for an installer. I really don't. I know many installers who can make a better job of installing a heat pump than I ever would. You know, you couldn't ask me to make a proper fitting, because I would be rubbish, and I just wouldn't be able to do it. But I can do. We can do all of the maths and take that pain away from them. I think the biggest one is just knowing where to ask, what to ask, who to ask, that kind of thing. Finding, you know, everybody should be able to do the correct integration and do the correct pipe sizing and everything like that. But unfortunately, because of the forgiving nature of boilers and what they are and have been in industry is that it's been lost. Some of it to some extent, because you're not doing it every day anymore. You know, and that's it. But I don't think it's difficult to our existing installer base. We're not asking them to do that little, not really asking them to do that much more practically, administratively. Yeah, I get it. I hear what you're saying, Richard. You're right. And people are trying to change things, you know. You know, the same heat loss calculations that you're being asked to do for a heat pump, you're not being asked to do for a boiler.
No.
But it's the same standard applies, funnily enough.
No.
If you went to a court of law, yeah.
I mean, I said a long time ago, things can be made a lot easier though. When you do an EPC for a property, you could state what the heat loss of that property is at -3 and put it on the certificate. This property needs 6 kilowatts to heat it at -3 degrees Celsius. Yeah, and that would be a real. I know you. I know that sounds simple, but at the moment, if people don't understand the EPCs, so they go ahead. I know there's calculative, there's formulas that you can calculate through the annual energy consumption, but at the end of the day, EPCs are a lot of guesswork as well. So if they were done more thorough and they did have a heat loss on them that was correct, then it would make the whole thing a lot easier. I appreciate you still got to size the radiators room by room, or get your heater meters correct.
We've already had that debate. The BRE, we've already had that debate with the BRE, Richard, because you're right. BRE are super clear that it's just an energy assessing tool. It won't be anything else. It should not be used for design purposes because it's just not accurate. That was one of the things that came out of MIS 3005. People used to do that 15 years ago, and that's where it fell over because it resulted in undersized equipment.
I think you're absolutely right. There's a need for a better, more accurate heat loss in 2 stages. I think, you know, something that I've been proposing to some of the trade associations is considering whether there's an assessment done on a property when the boiler's changed. So no additional work's done, but assess the property. What's the whole house heat loss? Are the radiators suitable for lower mean water flow temperatures? And just lodge that somewhere, and then lobby government to fund some of that or all of that upgrade to low carbon in the future when it's convenient for the homeowner to take that work, and it builds on that relationship between the installer and the homeowner, and that's a key part of this industry, isn't it?
Yeah,
the trust.
And I suppose taking your point a bit further, how much does an energy assessor get paid to do an EPC?
Not a lot.
It's tens of quid. It don't even reach 100. And certainly the ones I'm speaking to say to do it properly, to do it even an EPC properly, it's not enough money. Yeah. But we're still driven by market forces, aren't we? And incentivize that side of it. You know,
it's that big proposal though, isn't it? Where's the money spent? So, you know, the initial investment in having an energy performance certificate that is advanced, you know, and does give the correct heat loss calculations across the board, you know, facilitates not just heat pump installations, but the correct boiler sizing if they go down a hydrogen route, you know, the correct heat emitters. So, you know, what's the point in putting, you know, if the house has only got 5 kilowatts of rads in it, but the actual heat loss is 10 kilowatts, then, you know, the installer knows at that point, rather than, you know, having to do it themselves, which a lot aren't doing anyway, or don't necessarily want to do. So
there's a point. If you've got an MCS accredited heating system, and in the first place, it will have the heat losses for it for the future.
So, and that's something that government are really interested in when I've spoken to them, because actually that EPC is like that with the energy that's being used in a house. If you've got an accurate heat loss, all of a sudden government have got a much more accurate value for the energy that's being used in UK PLC. And more importantly, you could then focus on areas of off-gas or hard-to-treat properties with support mechanisms to get those properties up to scratch where you could change to heat pumps. And you're incentivizing the installer to be trained with that activity, you know, and for the homeowner to claim the voucher for him to do that assessment while he's swapping the boiler out because the boiler's broke.
The irony is the amount of EPCs that are completed, you know, there's dozens, you know, I think, you know, it's not just one that's completed, is it? And the accumulative time of doing all these EPCs, where one could be done, you know, at a fundamental point, at big changes, isn't it? So, you know, when, you know, because if the house isn't, you know, the performance of the house will inevitably change based on its upgrades, you know, whether it has double glazing fitted or the roof's then re-insulated or external, you know, wall insulation or whatever the property has done to it. But at these fundamental changes, the EPC should be professionally and, you know, accurately updated.
So guys, last couple of minutes, I'm going to give a minute each to try and sum up. Thanks so much. It's been an amazing range of topics, I think, that we've covered in the last 55 minutes or so. But bringing it back to installers, back to training, and one kind of key practical message or key practical takeaway that you might want to leave people with for a minute or so each. Could I ask you guys to go around and give your thoughts? Perhaps John, would you go first?
Yeah. Flow rate is king. In heat pump world, size your pipe work as if it's a double-sized boiler. If you've got a 16 kilowatt heat pump, it's a 32 kilowatt boiler. There you go. That would be I tried to work it out, but mine is flow rate is king.
Yeah. Okay. All right. Thanks, John. Mark?
The heating industry is changing. You know, it's moving away from natural gas. We have to go in that direction. There are opportunities there for installers to really grow, develop the business. And, you know, they're not on their own. The whole supply chain is in this together. And, you know, look around you for support. Those that want to change, you know, find somebody to support you, and we'll do it.
Don't be scared.
Nice. And Richard?
Just challenge. I would say from because I'm in supply chain now and I was an installer. So just challenge everything that you think you know, because you don't know that you don't know. So if you've got questions about your ability, there's people out there now that can help you with that. So keep challenging what you actually think you know, and you will just keep on top of it naturally, just by that peer learning or asking your colleagues for advice, or where to go and get, you know, where's been a brilliant training course lately, you know, who delivers the great training, and innovative new products. Keep looking out for them, because those are the things that ultimately will game change the market. It won't necessarily be the practices of individual actions. It will be the accumulation of everything that's involved, from controls to technology to people to practices.
Mm-hmm. Brilliant. So thank you all so much for your time, for your thoughts, opinions, your insight, and also everyone listening for all your questions as well. I focus mainly on the ones which were about skills and about training. So apologies if we didn't get to all of them, but I'm sure some of our speakers, and you can fire them off to us afterwards, and we'll do our best to kind of get back to you as well. So thank you, John. Thank you, Richard. Thank you, Mark. And we look forward to seeing you all again soon. There's plenty more talks going on the Elemental site. As you can see, all the details there in association with BEAMA this week. Thanks then, everyone. Cheers.
Cheers.
Bye-bye.